Today we're going to review solving systems of linear equations, and there are two main methods to solve a system algebraically. The first one is called the addition method. Now the textbook that we use calls this solve with elimination, but we basically call it the addition method because we're always adding variables together as opposed to subtracting. We always consider it an addition problem. So the goal of this one, when you're solving using addition, is you solve the system by creating additive inverses for one variable. Because once you do that, you can add the equations together and that variable will add to 0, leaving you with one equation and one variable. From there you can solve and then use back substitution to solve for the other variable. So here's an example of what how we do that, solve using elimination. If I look at my equations, 2x plus 3y is equal to 1, and 2x minus 3y is equal to 5. We want to create additive inverses, but if you look at this, we already have additive inverses here in front of the y. We have a positive 3 and a negative 3. So when we add these two together, my y coefficient is going to add to 0. So in this case, we just add x's to x's, y's to y's, and answers to answers. We keep everything lined up. So remember, there's an implied 1 in front of that x. So x plus 2x is 3x. It's not just 2x. There's an implied 1 there. 3y plus negative 3y ends up being 0. And then 1 plus 5 is 6. So we end up with a very simple equation. 3x is equal to 6. Divide by the coefficient, and you have an answer for your x value. X is 2. What you do then is choose one of the original equations. I'm going to choose the first one, replace the x in it with the 2, and then solve for y. So I'll do that over here on the left. So this is 2 plus 3y is equal to 1. You subtract away the 2, you get 3y is equal to negative 1, and it looks like y is going to be negative 1/3. Y is equal to negative 1/3. So as a coordinate, you could write this as 2 and negative 1/3. You can also check your answer in the equation that I didn't use. So if I check it in this one, I'm going to try to squeeze that in here. 2 times 2 minus 3 times negative 1/3 should end up being equal to 5. This is 4. This ends up being a positive 1. And the system checks out. Linear systems are nice because you can always check your answer into both equations, and they both should yield a true result. So next we have an example where we have to modify one of the equations to get additive inverses. If you look at my two equations, 3x plus y is equal to 5, and 5x plus 2y is equal to 7. I can either change the x's or the y's. If I create additive inverses from the x's, I have to modify both equations because 3 is not a multiple of 5. However, if I work on the y's, all I have to do is, since this is positive 2, I have to create a negative 2 in front of that y. To do so, I'm going to write right over this guy. I need to multiply the entire equation by negative 2, which means you multiply it by the 3 and the 1 in front of the y and the 5 on the other side. So here's my new system of equations. Now that first equation turns into negative 6x minus 2y is equal to negative 10. I multiplied every single term by negative 2. My second equation is unchanged. It's still 5x plus 2y is equal to 7. I add those two together and I get negative 1x, and my y's are going to add to 0, so I don't even have to show them. That's equal to negative 3. Therefore, x is equal to 3. Now I just need a value for the y. I choose one of the two equations. I'm going to choose the top one, and I'm going to have 3 times my answer is 3 plus y is equal to 5. So 9 plus y is equal to 5. Subtract the 9. 5 minus 9 is negative 4. So my answer should be 3, negative 4. I can check, since I used the top equation to find y, I'm going to check everything in the bottom equation. So here's my check. 5 times 3 plus 2 times negative 4. That's going to be equal, hopefully, to 7. 15 minus 8. It does end up being 7, so we're all checked. The second method for solving algebraically is called substitution. And we use substitution usually when one variable is already solved for the other. So that's usually the first step. If it's not there, we would solve one equation for one variable. So we either have like an x equals or a y equals. And then we take the expression that's on the other side and we replace the variable that we solved. We replace it in the second equation with that expression. And what that leads to is one equation and one variable. So when I have one equation and one variable, I can always solve it if there is a solution. And then I would use back substitution to find the other variable. So we're going to solve this system using substitution. It's a good candidate because I already have y by itself. So I don't have to do any maneuvering to get something, an expression to substitute in. What I will do is take this expression, the 3x plus 2, and I'm going to replace the y in the expression beneath it. So here's what I have. I have 2x plus, now I have the 3x plus 2, and I recommend putting those in parentheses in case you had subtraction in front, because then you'd have to distribute a negative. I have 2x plus the quantity 3x plus 2 is equal to 7. That gives me a single variable and a single equation. So now I go ahead and solve it. The 2x plus 3x plus 2 is equal to 7. 5x plus 2 is equal to 7. Subtract the 2, you get 5x is equal to 5. Divide away the 5, and x is going to end up being 1. Now this is easier to find the y because you already have y solved by itself. So I'm going to move over here, and I have y is equal to 3x plus 2. So y is equal to 3 times 1 plus 2, and it ends up y is equal to 5. So my coordinate is 1, 5. Since I used the top equation to find y, I'm going to check in the second equation. 2 times 1 plus 5 needs to be equal to 7, and it works, so we are good. We also use systems of equations to solve some word problems. When you have two different variables in your word problem, that is conducive for using a system of equations. So here we have a word problem. The sum of two numbers is 74. Sum represents addition. Is our equal sign, so 74 is going to be on the right side of the equation. Their difference is 28. So difference is subtraction, and this is our equal sign. And then it says, what is the smaller number? Well, we're going to need a let statement. Since there are two numbers involved, we can let x equal the first number and y equal the second number. You could label them larger and smaller if you want. And then we're going to write the two equations. The sum would be x plus y is equal to 74. And the difference, depending on which one's the larger and which one's the smaller, it's really irrelevant right now. X minus y is equal to 28. Well, we already have additive inverses, so I can add these two equations together. And remember, there's an implied 1 in front of the x, so when I add x plus x, I get 2x. My y's add to 0, and 74 plus 28 is going to be 102, which means x needs to be 51. To find y, you just put in y is going to be 74 minus 51. So that ends up being 23. Since I'm looking for the smaller number, it should be 23. So let's check. Their sum should be 74, and their difference should be 28. 51 minus 23. That's a 51 there. It's not a 57. 51 minus 23 is in fact 28. So we have checked, and it works. Finally, I want to show you a different type of systems equation, but this one should be pretty easy to set up the equations because everything kind of goes in order. We have 5 road bikes and 4 mountain bikes, and that is equal to $6,400. And then one of each is going to cost $1,400. So we have the two things that we need to find. So our let statement, we're going to let x equal the cost of a road bike and y equal the cost of a mountain bike. Since 5 road bikes added to 4 mountain bikes equals $6,400, that's our first equation. And then one of each is $1,400. We could solve using substitution, or we could solve using elimination. If I used elimination, I could get rid of my x's by multiplying my second equation by -5. This is just one of several ways you could solve this problem. So 5x plus 4y is equal to 6,400. Negative 5x minus 5y is equal to negative 7,000. Add them together and you get negative 1y is equal to negative 600. That means y is equal to $600. A mountain bike is $600. And then, since x plus y is 14, x plus 600 is 14, and a road bike is going to be $800. So, what does a road bike cost? A road bike costs $800. So that's just a quick review of solving a system of linear equations using addition or substitution.